Hello everyone, it's October 22nd. Alright, what we have today is... Hold on, I need to sign in. I cleared my cache yesterday because my laptop is just getting slower and slower and slower. Alright, now we see. Sort characters by frequency. Seems to be interesting. Nope, not done this before. Okay, given a string s, sort in decreasing order based on the frequency of the character. The frequency of the character is the number of times it appears. Return the sorted string if there are multiple answers, return any one of them. Okay, so E, R, and T doesn't matter which one. C, A doesn't matter which one. A, O, uppercase and lowercase. Well, I think a counter shall suffice. A counter shall suffice. And I think counter has a functionality already, right? Counter doesn't have a, what should I say? Let's see. Counter, what function does we have? So counter we have most common, right? So we can just call most common. Exactly. I think that shall do. Is this considered cheating? No. I'm just using a language that a lot of people are saying, oh, it's not that good because Python just went to the first spot in the ranking, in one of the rankings, and people in the comments like, oh no, I don't like Python. Python's bad. Python's slow. Whatnot. Well, with all the faults Python has, there's one thing that it does not have is it does not have bad libraries. It has a lot of support in the community. And just based on that, right? Just based on that, look at the from a collection import, right? Look at the collections, right? All the data structures in the collections, all the tools in func tools and iter tools and all of that. It's just amazing. It's amazing language. It's amazing. All right, so what we're gonna do is we're gonna call counter on S, right? And after that, we'll just call most common, right? And then we're gonna say we're gonna do join, right? But we're not gonna join this because if we say most common, we're gonna return tuple. So we're gonna return the first one, right? So we're gonna return the key, not the value. So key, and we don't need this in this, and return. I think this one shall be sufficient. Let's run it. Oh, I forgot about that. Okay, I forgot about that. All right, that's fine. That's fine. I think this is cool. I can do this. There we go. Yeah, I think this is cool. Let's no, let's get all the test cases and try it. Yep. So yeah, that's it. Yeah, I forgot a times v. We need a times v. 476 days. That's our streak. All right, so I mean, we can try. We can try not using counter. Well, if not using counter, I'm going to use a dictionary. So it's basically a counter, and I'm going to sort. So get a dictionary. I'm going to sort based on the value, and then so it's the same thing. So it's the same thing. So thanks to Python's very rich built-in library. Right? Built-in library. We can solve this problem in one line using counter. I mean, the runtime should be on log n, because the most common probably take, yeah, it should be on log n, but we don't know, right? It should be on log n, because most common, most likely takes on log n. All right, so what we have is what I'm trying to do. That's 4:51, so we're gonna record. This is 4:51 and the time. So code 4:51 and the time we got is 58. All right, 58 milliseconds and a 48% ranking. All right, let's see. Discussion. Yeah, it's one line. This will be the same. Reduce. Reduce. You can do reduce. That's fine. Bucket sort. Priority queue. Yes, you can do priority queue. That's on again. Oh, bucket sort. Wait, is bucket sort can be on? Not really. I don't think so. Bucket sort. That's a map. And buckets. Buckets frequency. That'll push. Oh, well, that is on. Bucket sort is on. Yeah. Bucket sort is on because we just go through the buckets, right? We go through the buckets. Yeah, bucket sort might be a, yeah. I have a one-line solution, just kind of forgot about the on solution. Yeah, let's try it. Yeah, bucket sort is a good idea. Oh, but that's basically just a sorting problem, right? Because you have to do counter first. And then you do the bucket sort. Maybe it is on too. Who knows? Who knows how most common is implemented? We don't know. But yeah, we can use bucket sort. So why spread on the time? What else do I want to see? Nothing else. That's about it. All right, so let's roll another one. This one is just, we're done already. We don't need to test case. All right, let's go to problems and roll another one. Let's roll another medium. All right, let's see what we got. That become red now. See that? It used to be a blue when it going round and round. Google. Yesterday. Oh, we have done this. No, we don't want to do one that we've done before, even though I forgot about this. Let's try it again. We want something that we have not done before. All right, pick one again. All right, this one probably not. Nope. All right, let's try this one. Oh, 59 like and 197 dislike. Oh, mamma mia, look at this. Ooh, what the hell? What did I get myself into? All right, let's see. You are the operator of a centennial wheel that has 4 gondolas. Okay, and each gondola has room for up to 4 people. You have the ability to rotate the gondolas counterclockwise, so counterclockwise, okay, which costs you running cost dollars. You're given an array customers of length n, where customer I is the number of new customers arriving just before the ith rotation. I'll do it some other time. This means you must rotate the wheel I times before the customers arrive. Wait, hold on. Length and where this is the number of new customers arriving just before the ith rotation. This means you must rotate the wheel I times before the customers arrive. You cannot make customers wait if there is room in a gondola. Each customer pays boarding cost dollars when they board the gondola closet closest to the ground and will exit once that gondola reaches the ground again. You can stop the wheel at any time, including before serving all customers. If you decide to stop serving customers, all subsequent rotations are free in order to get all the customers down safely. Know that if there are currently more than 4 customers waiting at the wheel, only 4 will board the gondola and the rest will wait for the next rotation, because the maximum is 4. Return the minimum number of rotations you need to perform to maximize your profit. If there is no scenario, to -1. Let's take a look. Customers 8 and 3. Boarding cost is 5. Running cost is 6. The number written on the gondola, number of people currently there. So start with 0. 8 customers arrive. 4 board, 4 waiting for the next gondola. The wheel rotates. Current profit is, it's not a full rotation, just like a half rotation, right? Yes, each rotation will cost you $6, and so that's the current profit. And now 3, so that we have 7 and 4 waiting, and the other 3 wait. So there's 7 people. Current profit is, so we have another 4 go in. So now we have 3 waiting. So the final 3 customers arrive. The highest profit is 37 after rotating 3 times. Okay. That's what we have now. Have 10, 9, 6. So have 10 customers arrive, and then we take away 4, so we have 6. Second round we have 15. So we take away 4, so we have 11. And then 6 rounds, so we have 17. So before the third we have 17. Right? And then the third one we can get 4, so we have 13 remaining waiting. And we have 1 more. 1 more is free because we got 3 rotations. We can do 4 rotations. So we can do 1 more rotation. So now we have 9 remaining. And now each one we unload when we load. Wait, we unload. So I have 5. And we load. And 1. 5 load, 1 load, and then that's it. So 1, 2, 3, 4, 5, 6, 7. So we have to rotate 7 times. 7 times 4. Boarding cost is 6 times. But everybody has a board anyway, so that's a 25. 25 times 6 minus 7 times 4. I mean, you want to do every single person, right? So that's 13 people. So everybody needs to be on, and we need to do 5 times. Because we have 3 waiting, so 3 has to go. It says people have to go, right? I think this is you must rotate. No. I think there's a saying that everybody has to go. You cannot make them wait if there's room. And so every time is 4. So this one it's deterministic. Every time is 4, so the 3 will go 1, 2, and 0. We don't move, right? But wheel still rotates. I thought we can avoid rotating. Wait, why do we still rotate if there's nobody waiting? You can stop at any time. If you decide to stop serving customers, all subsequent rotations are free in order to get the customs down. Waiting at the wheel, only 4 board, and the rest will still wait. I don't know, what's the trick here? Like the 0 customer arrive and then nobody's waiting. 0 board and 0 wait. The wheel rotates. Why do we rotate? 5 customer arrive, 4 board, 1 wait. 1 arrives, 2 board, 0 wait. So again, it's all of them, 10, 10, 20, 26 or 37. Everybody into big board. And just how many rotations? So can we just do 37 divided by 4? Yeah, it is 37 divided by 4. 37 divided by 4 is 9. Huh. Is 9. But we only need to go. Oh, yeah, 10 rounds. Oh, we have 9 round and 10 round, and then we have highest profit. Oh, here we go. Here we go. Oh, it's among the entire process, what is the highest profit? Okay, the minimum number of rotations you need to perform to maximize your profit. I'm still trying to understand what it's trying to do. But we do have to go through the entire, every single 10 to the 5th. Okay. So we go through every single round, and each round we just keep track on the profit. And we stop, right? We find the maximum, then we stop. I see. 4 board, 1 weights, 36. All right. And then 1 board, 0 weight. Now that one is a waste. So what? So we just go through all the scenarios? Is that what it is? I feel like that's it, right? So, I mean, if somebody's waiting, then you have to let them go, right? So if no matter how many is at the starting point, you cannot wait, because they say if there is room, you cannot make customer wait if there is room in a gondola. which means you cannot wait, like let's say, wait for 4 people to come, so they will go. So you have a maximum, all right? You cannot do that. If only 1 person arrives, you have to go as well. Yeah, because like even if just 1 person arrives, like in this situation, wait, not this one, in this one, right? No matter what, you're gonna lose money because the running costs are too high. Therefore, the best strategy is not run at all. But you cannot, because you cannot make customers wait. If they come, they have to go. So however many as the starting point, you have to get at least 4 of them on, all right? And then you rotate. Now this is the thing. Why do we keep rotating? Like in this situation, we keep rotating. Hold on. You must rotate I times before the customers arrive. Which means if I do not rotate, in this case, if I do not rotate, then these customers will not arrive, and then we just stuck, right? Then we just stuck. And we can terminate. But if we terminate at this point, then whatever we have is the current profit. Might as well just keep going to see. So well, again, I think this is deterministic. Let's try deterministic. See if it works. It's a weird problem. 1599. Yeah, it's a weird problem. Yeah, I'm gonna solve it deterministically. So like with nothing. Oh, let's see how difficult it is to solve deterministically. So what do we have? We have. I mean, this is a hint. Like all the computation is just number of rounds, and number of rounds is just the iteration, right? And then also the number of people on board, right? So basically, we just say res equals, we want a maximum, so we're gonna have math.inf, but it's a negative, right? So we're gonna import math. All right, so we say for remaining customers, right? Remaining customers. Oh, how should I iterate these things? Rotation, rot, equals 0, all right? And then remaining customers. Well, rotation is 0. Remaining customers is should be customers 0, right? Customers 0. Let's see. Customer length is 1, yeah, so customer 0. And then we say while remaining customers and rotation is while we have remaining customer or rotation is smaller than len customers, right? If it's smaller, then we should keep going. Now, what we're gonna do is the first round. First round is going to be remaining. So how many people are going, right? The number of people going. So that will be the so go equals the minimum of 4 and then remain. and remain equals remain minus equal to go, right? And then go. So res equals to maximum res. That's the first round. So first round. Oh, we need to compute a total number of go. Which is fine. We can just max res and or we need to keep track of the total number of go, right? So we have remain, number remaining, total customers that go. That's the total go, right? So let me say total go is 0. So go is equal to this, remain equals to this, total go plus equal go, right? And remain is this, total go is this, so rest will equal to total go times boarding cost minus rotation times running cost. Let's go rotation plus equal 1, and this is the rest equals maximum this, right? And go back, we'll do it again. Go equals remaining. Oh, I need to first do remaining plus equals to customers rotation, right? If rot is smaller than land customers, remaining, and this, if rot is smaller than land customers, remain plus equal to this. This is or, and actually remain can be 0. I just realized. But they're all 0. So while remain or rot smaller, and then we go in. If rot is smaller, we can do n equals land customers. So we can just replace this with n. If it's smaller than remaining plus equal to current rotation, right? The rotation. Haven't done yet for the current rotation. Now we got the remaining, and then we know compute how many we can go. And now we compute how many we can go. Remain will be minus this. Total go will be plus this. Rotation plus 1. Compute this. And then we'll go to the next rotation. So rotate plus 1, we'll go to the next rotation. Right? And in the next rotation, we get the new customers, and then blah blah blah. Once we finish all the rotation, if we still have remaining, now we come here, we keep going, and rotation, we can keep rotation up, right? We have to keep rotation up. We're just going to return res if res is larger than 0, larger or equal to 0, I think. Whether there's no scenario where the profit is positive. Yeah, larger than 0, else minus 1. I don't know. It's a weird question. Alright, so first test case, A3, 6, 4. Answer is 5 and 6. Answer is 5 and 6. 5 and 6. Answer is 3. Second one, 10, 9, 6. 6 and 4. Answer is 7. Third one, 340, 51, 192, answer is -1. Last one, 1010, 647, 647, 3 and 8, answer is 9. Oh, hold on. What are you doing, man? And now return a profit. Return the minimum number of rotations. The minimum number of rotations you need to perform to maximize your profit. So we're gonna say max prof, right? And res. Res doesn't really matter actually. It can go 0. Okay, so this is max profit. Oh. Damn, I need to compute the new profit first. So new prof equals this, right? New profit is this. And we say if new profit is larger than max profit, then max profit equals new profit and res equals rot, right? Res equals rot. Res equals rot. Is it equals rot or I don't know. Like if it's 0 customers, I don't have to go. That's the thing. Yeah, I feel like if it's a 0. Oh, if I don't go, then there's no profit, right? You have to go in order to find profit. Yeah, because if it is 0 and just stuck there, right? That's a restriction. You got stuck. We have to go to see what's happening. So we have to go. So if this is larger, the new profit after rotation, then res equals this. If new profit is equal to the max, then we don't update because we want the earliest, right? So we're going to return res if max profit is larger than 0. Otherwise, we return this. Okay, so this one shall be right. So customers, boarding cost, running cost. This is a min operation max profit. Customers, boarding cost. No, that's not customers. That's a running cost. Okay. I'll pass all the test cases. Yeah, but I'm not sure. It just feels weird, right? It just feel weird. Let's say what if we have like 0, 0, 0, 0, 0, and yeah, let's say this way, and like say 10, not 10, let's 4, right? 4. That's too many. Just a 2, 0 and 4, right? And the operating cost, like if I wait, is going to be 0. But if I go, then I would go. What do I want to achieve? I want to say if I wait, it's going to be better. Well, if you wait, let's do this. We have 4 at the beginning, right? So 4 at the beginning, and then we have a 0, and we have a 1, right? So 4 at the beginning, we need a positive profit. Let's just say it cost us, it will give us $10, so 40. So we go 40, right? And minus the operation cost. And we wait. So it's gonna be 40 minus some operation cost. And then a second is 0, and I choose to stop. Or if I go, then it's going to be 40 minus operation cost times 2, right? And I want that to be negative. Yeah, let's just easier, just 4 and 0. Right? 4 and 0. So 4 comes in, will be positive, but rotate twice will be negative. How about that? Yeah, and if you want to get them down, you'll take. Oh yeah, this one will return 1, right? In this case, it will return 1. Let's say if we got $10, I'll get 40. Then rotate once. Let's say it's gonna take 10. All right. So 40, no 20. So first one we got 40, we minus 20, so the profit is 20. If we stop there, that's one rotation. If we go another one, go another one, then that will just get lower and lower. Let's see how this one goes. Yeah, it is 1. Yeah. Let's see. Yeah, that's it. It's a weird problem, indeed, very weird. Not sure what are we trying to achieve, right? What are we trying to achieve? This is a weird problem. So this is a weird, all right, weird problem. There's no optimization. There is no optimization because we are forced to keep rotating the wheel because otherwise new customers will not arrive, right? Otherwise will not arrive. So basically we just, so everything is deterministic. So everything is deterministic, and all we are doing is keeping track of the profit at each rotation and record the earliest rotation that leads to maximum profit. And that's it. And then it will run in on time. Actually, no. It's actually not on. It's a sum of that. So we're running let's say n divided by 4 actually, right? On divided by 4. So n is the sum of all customers. And this one, they're quite slow, 2,436 milliseconds. 58. All right, let's see how other people say. This is a weird, very weird problem. Is it one of the contests probably? 2020, Owen Greedy. It's fine. Don't worry about people downloading. I will not care. Sum with plus boarding. Oh, but I mean, it is greedy, right? Like you always board the maximum number of people possible, but that is because we have to do it this way, right? There's no way because it's required, right? It's required. So yeah, it's the same thing, right? It's the same thing. Yeah, sum minus. They don't have a to go, which is fine. Run plus plus. Yeah, it's the same thing. This is a weird problem. That's a very weird. Oh, nobody's complaining, huh? It's all simulation. Wait, is this like under the category of simulation? But if it's under the category of simulation, then it makes sense. Yeah, I will not call this greedy because it's required, right? It's not greedy, it's required. Oh my god. Oh. Ooh. Nah, I'm not gonna read this. Yeah, it's a weird problem. I like it, don't like it. Nah, I'm not gonna do this. It's a weird problem. I don't know. I don't know the purpose. I don't know the purpose of this problem. All right. Anyway, we're done. 2 questions today, so that's good. I'll see you guys tomorrow. Saturday. It's a difficult one. I'll see you guys tomorrow. Adios.